Hello and welcome to this week's edition of Underserved, the podcast for the rest of the tech industry. I'm your host, Andrew Gelina. I am fortunate this week to be joined by Russ Wilcox, head of Sanson US. Russ, welcome.
Thanks so much for having me.
Russ is a physicist turned data scientist over the years.
Yeah, it's been quite a journey. I got my start in 2007, working with the U.S. Geological Survey, doing data science for alternative means of energy, looking at a substance called methane gas hydrate. And since then, I've been attracted to computational solutions to very challenging problems. And I think that summarizes where we're at with data science and AI today.
So methane gas hydrate, does that have to do with fracking at all, or?
No, not really. So about 500 meters below the seafloor on continental shelves, methane is actually more stable being a solid than a gas. And what we were interested in looking at the physical properties of the sediment, looking at whether we could classify coarse-grained versus fine-grained, and really kind of quantify how this stuff formed, because there's far more of this than oil reserves in the world. And more importantly, methane is a far more potent greenhouse gas than CO2. So we were looking at it both from an alternative means of energy standpoint, but also a climate crisis standpoint.
So you got into data science. You know, there's a lot of hype around it these days. I mean, everyone's talking about machine learning and AI. And if anyone has like an if-then statement in something, they're like, oh, it's artificially intelligent. So how can you help people kind of separate the hype from the reality?
We should take a step back and realize as a society as a whole, we're not at the level of SKYNET taking over, or I think it's called Legion in the new Terminator movie. But rather, we should take a look back and see, well, we've been really doing artificial intelligence since the 1800s. From basic problems in linear regression that you learn in high school. Sure, we didn't have the robust computational infrastructure that we have now, but that really laid the groundwork to where we're at today. And for any business entering the scope of data science or AI, I'd recommend them to really kind of step back and think about, where do you think you guys can have the strongest ROI, your strongest return on investment? Because it's not going to be with these kind of moonshot projects to automatically create the next perfect chatbot or image recognition software. It's going to be in the ground where you're building infrastructure to automate processes. So I think the first step I would recommend for any business thinking about AI and data science is think about, where are you thinking about outsourcing your company now? Is this in terms of just automating processes? Is it for classifying documents? That kind of will set the tone for the majority of businesses entering the AI. That's the automated portion. The next step up is the cognitive portion. So we're not talking about, again, Arnold Schwarzenegger being fully cognizant of his world around us as a Terminator, but rather these predictive models that, stocks are using to forecast, or bookstores are sending you personalized recommendations from. You're using the world around you to infer some future behavior. I think that's where we're at the cognitive level. And the final step in terms of this is this true generalized intelligence, having the computer be able to make robust decision points to really optimize society as a whole. I think you're seeing those moonshots at companies like Tesla and Uber with their self-driving cars. And even though that's the viewpoint of society as a whole of where AI is, it's important for businesses to remember that even if you have a relatively small data set, you could use traditional statistics and traditional machine learning to really have a strong impact on your business.
The first thing that I saw was like recommendation engines popping up, right? Everyone's kind of familiar with like Netflix and Comcast. And if you like this, you might also like. How is it kind of in layman's terms being trained under the covers? How does it learn?
Yeah, so there's two viewpoints of how to understand a recommendation engine. The first is what you call collaborative filtering, where essentially the recommendation says, okay, Andrew likes X, Y, and Z movies. We noticed Andrew and Russ share X together and Y together, but not Z. So it's likely that Russ might like Z. So we'd recommend to him Z. The second portion is a content-based filtering, where essentially you look at the content of the item, whether you're looking at a mathematical representation of that, whether in terms of user clicks or popularity or of all of these other types of indices, or the actual unstructured text to have the machine learn what similarities are. And in fact, my company, Sanson, kind of specializes in that content-based, where we just deployed a new recommendation engine for Gyldendal, Norway's largest book publisher, that was actually trained to read the descriptions of books. And I think that's where you're starting to see the robustness come out of recommendation systems now. But we have to really understand that recommending products is a dynamic process. You, Andrew, might wake up one day and say, well, that movie genre, I'm done with it, right? There's no way for the computer to know that until you give it feedback. So the last step to make these more robust is to add in that feedback component where you're exposed to an item and you can click, say, yes, I like this, or no, I don't. And that no, I don't, or that yes, I do, can then be fed into a reinforcement learning model where the computer is able to actually make decisions based on your unique input. So I think that's kind of where we're at in terms of these personalization engines that we hear all about today.
And so how is a neural network similar or different from that? And how is it different to train something as opposed to programming it?
Yeah, so essentially, the best way to think about a neural network is guess and check. In your traditional math class, right, you're probably in ninth grade, you have a whole bunch of data points, and you want to say, what is the best fit line? How can I create a model that would best predict that behavior? So I think that's the first place, is to understand what a model is. All a model is some sort of mathematical representation for you to make a future prediction about something. So the next step is how that model is trained. So there's a variety of different methodologies based in statistics and computer science and mathematics for you to come up with a way of robustly quantifying the uncertainty of that model and to classify whether that's a good model or bad. So a neural network is just a certain architecture of a way of approaching these types of problems, where the neural network doesn't really know anything about the system. So what it does is, if you remember enough of your kind of algebra 1, if you're trying to fit a line, you're guessing what the slope and that intercept is, right? Well, we could say, okay, I'm just going to randomly guess what that slope and intercept is. Okay, and then I'm going to use that as my model. I'm going to plug in my data points and see how it fits. Well, most likely that's not going to be a good model. Your prediction might be off by thousands or hundreds or whatever your unit of quantification is. So what happens now is that model gets feed back into this architecture using a process called gradient descent. And essentially it re-guesses. So it learns what the current model is. And then it progresses forward. If you have a better fit, it knows how to kind of tweak those model parameters. And you iterate this through hundreds or thousands of steps. And you eventually come up with the model that fits your line. So that simple framework can be extended to any type of problem in machine learning, whether you're dealing with classification or regression. You might not be able to really understand what the neural network is trying to predict in terms of these weights and biases, as we call them. But it's that same logic. You're kind of guessing and checking.
So how do you know if it's getting better? For instance, I have a Tesla and I'll drive it sometimes and I'll put the autopilot on. They'll give me updates, maybe call it once a month over the air. And you can tell that the engine that does the autopilot has definitely updated because it'll behave slightly differently on the highway. And maybe it dives a little more towards an off ramp or doesn't when it's on. How do you kind of trim something or say, yes, good computer, no bad computer in order to make it better?
So there's several steps you can do to do that. The first comes into what data are you using to train this model? So all it means to train is to, again, figure out what those slopes and intercepts are in the final model. That could be high dimensional for your Tesla problem or whatever problem you're dealing with. So the first step is to break your data into what's called a training set and a test set. So the training data is what gets fed into your initial model, and that's what iteratively goes through this process of guessing and checking. So what happens is that the data gets fed in, it creates an observed output. You measure the distance just like you would when you're in high school measuring the hypotenuse of a triangle. You're trying to minimize this distance between your observed and your predicted value. And that's what is getting fed back into the neural network to help it make it learn and how to improve this iterative process. So once that's done, you could say, hey, I'm golden. My model is done. Here you go. Let's put this in production. But that's not a very good case, right? Because you're just testing it on or training it on one set of data. You want to see, how does the model behave under new circumstances? So this is where the test set comes in, where you start saying, okay, I have this model that I think trained well. I have these metrics called accuracy and loss that I can quantify. But let's see how it performs. So I can put in my test data and see, again, compare those distances to the prediction versus observed and see whether this is a good model or not. So typically, you're looking for a model that is not overfit, i.e., it doesn't connect every single one of those little points in your linear regression. And you don't want to have a model that's called underfit, where it just misses some signal, right? So you're dealing with this trade-off of, am I fitting too much? Am I not getting enough signal? And that has repercussions for your problem. So that's where you start looking at your testing data and validating, saying, does this make sense? If it doesn't, is there something else I can do in the training process? And that's the same thing that's going on with your Tesla. So these computer vision problems are trained on a series of neural networks called convolutional neural networks, which essentially decomposes an image into arbitrary features and edges that can be used to recognize boundary points and what objects are. So when you're thinking about the case of your Tesla, you want to think about, okay, what features might my stop sign look like? What is the computer going to do that? Well, I want to make sure that enough of these stop signs are labeled correctly, right? So when you feed these data into a model, they typically need to have some sort of labels, right? For the computer to recognize that a stop sign is a stop sign. So you need to be able to have a person in there to say that, oh, okay, computer, here's an image of this hexagonal or octagonal shape that's red and says stop. That's a stop sign. That's not a gas station or something like that. So there's this layer of labeling that goes into effect as well for training that you have to consider. But that's kind of how this process works in general.
All right, that makes sense, because I know they're touting on their most recent release, like, oh, we know what traffic cones are now. And they'll actually show up on the little UI on your dash while you're driving by them.
Yeah, what's really interesting about that is we really don't know what the neural network is learning. It's giving us this perceived output of a traffic cone that we said this is a traffic cone. But you have to remember the computer is learning some high-dimensional mathematical representation of this. And Anders Sanson out of the University of Oslo in Cambridge had a really good talk on this and is a proponent of this research of getting to understand what the neural network is actually learning. So let's say you're an alien and you know nothing about Earth. You know nothing about anything here. But we put you in a room like we're here. And all I show you is an image of a stop sign with a blue dot. And we tell you that that's a stop sign, right? There's this image of a stop sign, but there's this blue dot or this blue bar at the bottom. As an alien, are you recognizing the stop sign as the actual stop sign as we say that we recognize it is? Or is it the stop sign with the blue bar? Or is it the blue bar? Is it the orientation of the blue bar? So that's the thing that we have to think about in terms of machine learning and computer vision, is the computer is not really understanding the metaphysical features that we're comprehending. It's some high degree of mathematical representation, which has very important societal impacts, because we could say that I think your Tesla probably has an accuracy of somewhere like 98% or something like that of being able to correctly classify your images. And you'll say, okay, well, 2% isn't that bad, right? 2% is not that bad of error. Well, if we don't understand what the computer is learning, we can exploit that 2% with something we call an adversarial attack, where we can jumble up this image of a stop sign and put in noise that you might not even see. But that noise interferes with the signal that the machine is learning and will tell you that that stop sign is in fact a cheetah. And in fact, it will tell you every single stop sign is a cheetah when that adversarial noise is laid over that. And we don't really have a way of detecting that.
Is that like electromagnetic noise or how? Or
No, so it's think of it as white noise that you'd fill a computer with or an image with in Photoshop, right? You have all the different layers of these types of filters that you can use, right? Those pixels, you introduce some new filter and it'll change the color. It'll have some effect on that pixel, right, to give it a visual difference. Well, this noise is the same thing, but it could be just very, very small perturbations in the image quality or some portion of the image space that we really don't understand that is not even recognizable. But when the machine learns that, that's where you have the issue because the machine is not learning this physical feature of the stop sign. It's learning this mathematical representation that we can't really quantify or understand. So if you interrupt that somehow with this layer of noise, this adversarial noise I'm causing it, that will consistently exploit it to always misclassify. So I think there are definitely areas of active research still going on to determine ethically at what point can we say these neural networks for your Tesla are good to go or not.
are safer than humans or not safer than humans.
Yeah, and I think it's totally problem dependent because I think it was the FDA in 2018 finally said that deep learning is better than humans for diabetes detection. So what they did is they had a neural network architecture that would go in and actually take an image of the retina. And I guess I'm not a doctor, but the image of the retina or the eye has some sort of features in it that doctors use to detect if you have diabetes or not. And finally, that surpassed a certain accuracy that the FDA put out and said this is a viable test for detecting diabetes. So that might be good because you're having this layer of human interaction where the doctor can come in and say, well, yeah, the computer says this and I have all these different test results from my own experience that can back this up. It's not a real-time thing. But rather you have a car going down the highway, trying to veer off to your turn that you're talking about, and it sees the slow down sign, right? We're expecting that the computer is always going to slow down when it sees that sign. But if we don't understand what mathematical representations are being learned, you could perturb that sign to, say, speed up to 100 miles an hour. I'm just using this as a test case, but this is kind of where you're getting into this weird boundary of what's ethically viable for neural networks versus what's viable and safe to do in this kind of AI-human blended model.
So speaking of ethically viable, 23andMe, has caused some alarm here and there with folks that found out they're related or not related. And now I see that they're doing some stuff with predicting your relative risk for certain diseases. I would have to imagine that insurers would want that sort of data so that they can rate you and better know from an actuarial standpoint what sort of risk you are, whether or not they want to take you. If so, what they want to charge you for a premium for both life and health. What other sort of ethical dilemmas do you see?
Yeah, so I think what sums this up is it was a cartoon I saw someplace of this 1950s couple. The guy is talking to the radio or something like that, screaming out about the sports match or something like that. And his wife says, oh, don't, honey, the Russians are probably listening to you or whatever. And flashback to now where we actively do that into our Alexas, right? So we're freely giving away our data. And in the States right now, it's the Wild West. There are very minimal data regulations outside of healthcare and HIPAA that companies have to contend with. Unlike Europe, where there's something called the GDPR, the General Data Privacy Regulation specifying what can be accessible or not, something that my company very much values. But as a society, we have to really think about at what point does convenience overshadow privacy versus civil liberties and this conglomerate of issues, right? And I think about, I just got a new Toyota Tacoma, 2019 Toyota Tacoma. The thing's great, but it's starting to, in conjunction with my phone, learn my behavior. it learns that, okay, Russ regularly goes to Dunkin' Donuts at 8 a.m. and it's giving me traffic updates. And while that might be convenient and societally good, at what point do we say that this is enough? And I think that's where you're talking about with the 23andMe and some of the bioethical issues of this. Now we're getting into this land of big data. What defines user privacy if I give my genome to you to sequence, right? Maybe that's very important to me to understand what risk factors I have in my familial health history or whatnot. But do I, as an individual, want that data then given to other companies or other entities without my approval? I think these are very real questions that society as a whole has to start grappling with to be able to make informed decisions in regards to some of the more robust features that we can see have great societal success.
Underserved is fortunate to be sponsored by Syrinx, the developer-founded, developer-run software consulting company. Syrinx provides bolt-on software development capacity to accelerate your software projects. Syrinx works with your team and your methodology, on-site or off-site, to deliver on time and on budget. They work in any technology stack: React, Angular, Java, .NET, Python, front-end, back-end, NoSQL, MySQL, any SQL you can come up with, they have experts. You need architects, developers, QA folks, project managers, analysts, data scientists. Syrinx can help everywhere in the software development lifecycle, anywhere in the United States. Syrinx also does complete outsourced software project development if you need a turnkey end-to-end solution, or if you just need an individual resource to fill a development gap. With 100% of their resources onshore and a 20-year track record of success, you can trust Syrinx to get it right the first time. You can reach them today at syrinx.com or 888-579-7469. That is 888-5-SYRINX. Expand your software development bandwidth at syrinx.com. Yeah, I think part of GDPR, there's also a right to be forgotten. So
yes.
You can say, I don't want to be part of this, or I want my data anonymized and not traceable to me. And
yeah,
I think that sort of thing makes sense for the United States, but I agree that we're more Wild West and leaning towards, let's see what we can do instead of, should we?
Yeah, and I think you see this echo in society through the use of films and literature and whatnot. And if you look at the 90s, right, with all of these movies like Jurassic Park, specifically Michael Crichton as an individual, he was very concerned with the humans elevating to the level of God, right? So you have this idea of, is science now surpassing God? Is that ethical? Where do we start having these conversations? And now today you're seeing that same type of societal cognizance in the film industry. I just saw the latest Child's Play movie, with Chucky the murdering doll, and instead of having a dead murderer possess this doll, it's a disgruntled programmer that disregards his safety protocols or something like that. And we might chuckle at that, but I think that's some of the points that we're starting to get at. We don't have to quite worry about quite yet. This idea of generalizable intelligence, the computer's not going to make its own decisions quite yet. Is that in the future, maybe 50 or so years? Probably, especially with the advent of quantum computing. But I don't think we're quite there yet. But regardless, we as a society need to grapple with this idea of, how much data can I give away? Do I have access to the data? Is this a fundamental right of mine to have this privacy of my data? Or do I sign that away when I need a lawyer to read these terms of service agreements that are all legalese that you just click I accept because these things are always there? So who knows what data you're giving away? And I think we're at the point that Pandora's box has already been opened, right? Now, how do we ethically grapple with that is the question I think we're starting to see tackled at the states level. I think California is in the process of putting into legislation some type of general data privacy act or something like that. But I think as a society as a whole, this is something that we need to start thinking about actively.
Yeah, in America, we tend to say, give me convenience or give me death.
Definitely.
Think about the consequences later. So tell me a bit about what is your company Sanson doing with AI?
Sanson itself was actually formed in 2013 in Oslo, Norway, really seeking to create a more personalized transaction between consumers and companies. And so essentially, we've been working with some of Norway's largest entities like Gyldendal, their largest publishing company, kind of like a Houghton Mifflin Penguin type. We've been working with Aptic, which is a big financial firm, kind of like JP Morgan Chase doing predictive modeling and whatnot. And we've done some really interesting problems in those fields, creating personalization engines and predictive models to really have a strong societal impact for our users and our clients for a strong return on investment. In here, I started consulting in 2018, worked with an app company called Pizziz doing some neat generative signal processing, and then started working with a company called For Patient Care doing predictive modeling on whether you're going to show up to your appointment or not for your eyes, because that was a substantial loss of revenue for them for these no-shows, they called them. And in 2019, I had been working for Sanson for about a year as a consultant, and we had the idea of saying, hey, we're both on to something really, really good here. Sanson has a strong base in Oslo, Norway, with a team in Dhaka, Bangladesh. And I had developed a robust clientele here in the States. And we came together and said, well, why don't we start a Boston office? And it was mutually beneficial. And that's kind of where we're at now. So right now, we're really working with our clients on an individualized basis to help them understand the points in their business pipeline where data science can yield a strong return on investment. Now, this might be as something as trivial as automating some process for the intake of unstructured textual data to these really robust personalization engines that are saying learning to read books and recommend them and have this user interaction. So we work with companies, both small and large, to really help them understand their data, create strong data practices, and create deployable, scalable models to have a strong return on investment.
If I'm at a company, how do I kind of recognize, oh, this is something we could benefit from? Is there a certain company size? Is there an amount of data? Is there an industry? Most of what you said seems to be B2C, like business to consumer, where you have a large number of customers that might need personalization or recommendations. Like, what are the things that you look for to say, this might be a fit?
So I think any business, and I'm saying this because I'm a Bayesian. So a Bayesian way of thinking is a certain statistical approach where you can specify your prior belief in something. And I have the joke that I'm specifying my prior belief that, yes, companies need to be cognizant of the amount of data they have, right? If you have 2 data points, there's not much we can do, right? The data has to support a given hypothesis. So the more data you have, the more likely that you can succeed in some sort of machine learning model. That being said, if you're a startup, we've worked with several startups who have smaller data sets. There are ways to overcome or minimize, I think is a better way to say, minimize the effect of small data through data augmentation, through data mining practices, kind of these base models we can come up with. There's avenues for companies with small data to create insightful decisions. That might not be in the form of robust predictive models. It might be helping you just understand, okay, what segment is buying your product the most or who's using your product the most. But I think for any company that's starting to think about AI, the first portion is think about where you can automate. Have you noticed the need to automate certain processes to streamline your business? Have you thought about outsourcing? Okay, if you started to talk about outsourcing for data entry, that's something most likely a machine learning model can help with, whether it's identifying and tagging documents or classifying. That's one approach. I think that's the ground up approach. The second is hey, we've been around for 50 years. We know we have 5 terabytes of data. Someone come in and start analyzing this and trying to figure that out. That's another branch of what we do. We come in and we say, okay, well, you now have this wealth of data. What are smart questions you can ask about that data?
What are some of the tools you're using? Is it Hadoop? Are you using some Python to help load this stuff?
So we're a strong Python shop with a strong Java influence as well. If you look at any type of machine learning, Python has just dominated. So in terms of structure, in terms of engineering, in terms of architecture, we really look at the problem you're encountering before we recommend a solution. We have experience with Hadoop and Cassandra and Microsoft Azure, and we really want to understand, are you dealing with something that requires a data lake type of solution where you have these just files dropped massively into the storehouse that maybe need to be analyzed once a month or something like that? Or are you dealing with an API request coming in daily that are 300,000 of these requests that you need to store and actively monitor, and something like a Cassandra data store? So from the architecture, we have experience in Hadoop and NoSQL and SQL, and a lot of these microservices put out by the Apache Foundation, such as Spark and Kafka, and being able to create deployable pipelines for our models.
So when you take your data scientist hat off and you're having fun, what do? I think you play saxophone?
Yeah, so I'm unique where I actually started working in data science in 2007. And if you look at my CV and my birthday, you'd say, hey, this doesn't make sense. That would have made him 16. And that's true. I was a full-time federal employee at the age of 16 with the USGS doing data science. I'd work 40 hours a week during the summers and 20 hours a week during the school years, all throughout college and high school. And so when I graduated college, I knew I wanted to get into data science. I knew I wanted to get into computational physics, but I was tired. I've already did 7 years of this. So the Russ Wilcox Jazz Group was founded. So I actively performed as a professional jazz musician from 2013 to around 2016, where we would have anywhere from a trio to a full 16-piece big band. We got into the Boston circuit, and we were the go-to function bands for Brown Harriman Brothers, the Newport Mansions down in Rhode Island. And then, of course, we'd have the more fun stuff where we do our own original compositions and play clubs in New York and Boston and doing the jazz festival scene.
Wow, that's cool. Do you still play now, or?
Yeah, so I still practice. I think one of the things that got me into jazz is one of the things that got me into data science, right? Jazz itself is this highly complex musical art, kind of like data science. It's this highly complex art to make predictions about the future, inferences about the world around us. And I think being able to kind of, as cliche as it might sound, leverage the left and right brains, the creativity versus the analytical, that's kind of where you got into jazz. And I think about my own practice routines. I still practice, and they're highly algorithmic, where I'll go through and look at different combinations and perturbations of notes for exercises and whatnot. And I think that's the beauty of the art form, is that it has that highly intellectual approach to it.
Yeah, I've definitely seen the crossover with a whole lot of folks who are deep into software development, data science, et cetera, where they're also into music, because music has a sort of math to it, whether it's the time and the measures and how things lay out and how they combine. There is sort of an algorithm to most songs, like verse, bridge, chorus, verse, bridge, chorus, and how they fit together. Some folks I've seen can go real out there on the creative end, and get very mathematical, and some with a more soulful and accessible approach to what they're doing. What are the folks that you play with? Are they also data scientists or more?
No. So I had the pleasure of being close friends with a couple individuals who were really the creme de la creme of New England Conservatory and Berklee College of Music. When I was applying to undergraduate, I actually applied and got into Berklee and UMass's music program. And it was a tough decision whether I wanted to pursue music full-time or continue in physics at the time. And I was lucky enough to be in Boston, which has such a strong music scene, have the connections that I did, to be able to go out and gig with some of these guys are the world's leading jazz musicians now. I think a drummer I played with, Anthony Fung, is playing out in Japan and Los Angeles. I saw on his Instagram feed the other night. And what a pleasure it was, what an experience it was to kind of be in this jazz scene of Boston, study with Jerry Bergonzi and George Garzone and Greg Abate to really kind of get into the essence of what jazz is in general. And I think that has made me a better career data scientist because it's forced me to think about problems differently. It's really expanded that creative side of things. And I'm very, very blessed for the opportunities I had to be able to play professionally.
Yeah, I think you really snagged the best of both worlds there because it's really hard, even if you're a great musician, to make a great living at it. And, there's certainly tons of demand in the Boston area for data science. So I think you kind of drank from both cups there.
Definitely.
All right, Russ, anything else you want to add or parting words for our folks?
I think in general, if I were to talk to any individual about the state of data science, the state of AI is twofold. To recognize that there is alarmist rhetoric out there in terms of SKYNET taking over. If you look at any type of major technological advance throughout human society that's been there, that these concerns, although theoretically possible, are still far off. We're not at the point of generalized intelligence of a T-800 Arnold Schwarzenegger Terminator coming back and taking over the world. But on the other side, I think I would encourage those individuals to really think about where are they using their data in everyday life. I think you should talk to your kids about your data, what data is being generated just through Facebook and Instagram or these clicks. If you're paying attention to society as a whole, I think down on the Cape, there was an interesting Supreme Court case that was just heard by the SJC about tracking of license plates over the bridge through the use of automated AI cameras. And I think anyone, whether you're a data scientist or not, should think about the state of data, what data is out there, and your digital footprint, and who has access to that. And I think if you start thinking about this critically, you'll be able to recognize, there are some really strong positive societal outcomes. But then you'll start thinking about at what point do we cross that line?
Definitely something to consider, especially in this day and age with all of our personalization and social media data out there. Where's it going? What's it doing? Where's it leading? Well, thanks again, Russ, for joining us. And folks, we're going to have probably copious show notes with some good links to all the stuff we've been speaking about. There's definitely a lot of follow-up research and topics. You can also give us feedback at Underserved, UNDERSERVED @Syrinx.com. You can also tweet at me. I am @Andrew Gelina, GELINA on Twitter, if you have any show feedback or are interested in being a guest. So thank you very much for listening to Underserved. We'll see you next episode.